This is a presentation on the Bloodhound 5 gas chromatograph. It is designed to address the Series 5 Bloodhound, what is specifically also known as the Enhanced Bloodhound. This presentation also addresses some of the larger points in there that seem to be hanging some folks up that are used to the older Bloodhounds, as well as some of the common questions that we have seen. First thing to cover on the Bloodhound 5 gas detector and gas chromatograph are some of the features and benefits of this unit, because a lot of people don't know they all exist. So we're going to cover them here real quickly. As you know, it's a real-time total gas infrared hydrocarbon system. It also uses a real-time set of sensors for oxygen, carbon dioxide, and hydrogen sulfide. As we are probably aware at this point, the standard Bloodhound reads C1 through C4, and it has an extrapolated real-time model and it uses a percentage-based system. This output is based on the total gas number and will give you an extrapolated real-time of the heavy gases as it passes through the chromatograph. It has quadruple data redundancy into its own internal memory systems. First, to the flash drive that's plugged into the face of the instrument. Second, the internal SD card storage. Third, to the internet storage at the Bloodhound server system. And fourth, from the use of the Eyeball Instrument's gas chart software. So technically it could be more than quadruple, but it's at least quadrupled. The Bloodhound 5 has full internet-capable monitoring and utilization as well as remote logging. There's an awful lot of power over the Bloodhound remotely that you or Eyeball technical support can help you with, not just in changing it, but certainly in looking at the data and evaluating it with you. The Bloodhound is fully compatible with the Well Information Transport System, or WITS system. WITS utilizes a standard format that was set forth by the ANSI Standards Board. The Bloodhound follows that format. We work with any WITS device that also follows the same format, which includes almost all rig sites. Eyeball Instruments has a number of software packages that allow the user to better utilize the equipment over time and in multiple places. Gas Chart utilizes an interface to the Bloodhound equipment. Real-Time Data Viewer helps keep track of real-time data. Eyeball Instruments also has an online presence that allows for users and customers of the Bloodhound equipment to keep track of the equipment from distant locations, as well as the ability to notify you in case of an equipment alarm. The local PC software Gas Chart also has the ability to notify you in case of an alarm. When you receive a Bloodhound gas detector and would like to utilize the online features, just call technical support at 405-570-4449 or through support at iballinst.com. That's eyeballinst.com. The online technician will be able to help you and get you set up for an online account at eyeballremote.com. The Bloodhound 5 has a rather unique power system in that it can utilize both 120 volt AC or 240 volt AC power from the rig system power. This power supply keeps an internal battery system charged, so in case the power is dirty, bad, or has low frequency, the internal battery supply will keep the Bloodhound system running even if the power has been lost for up to an hour. The Bloodhound 5 system has an internal chromatograph capable of detecting amounts of methane, or C1, ethane, or C2, propane, or C3, isobutane, or IC4, normal butane, or NC4, isopentane, or IC5, and finally, normal pentane, or NC5. The Bloodhound 5 has the ability to work off two internal scales. We call it the Enhanced Scale and the Standard Scale. Eyeball recommends the Enhanced Scale since it has the most adaptive and accurate reflection of the gas units that is currently being analyzed. The Bloodhound 5 has been upgraded to include new brushless pumps that have a minimum 20,000 hour lifespan, which is a 100-fold increase in life over the previous brushless pumps. There are two of these new brushless pumps in the new Bloodhound system. At times, condensation will accumulate in the sample line, otherwise known as polyflow. This condensation is mostly water, but it can have other hydrocarbon contaminants as well. The Bloodhound is manufactured to be able to digest a little bit of this condensation, but not very much. Internally, there's a 0.1 micron filter that is hydrophobic and does an excellent job of stopping most condensate. However, if too much condensate is allowed into the Bloodhound, then damage to the system will occur. We recommend that an Eyeball Instruments catch jar is used to catch this condensation. This jar is designed with a check valve in order to shut off the intake in the event too much condensate is collected at any one time. This catch jar should be utilized both at the shaker and inside the trailer within 5 feet of the Bloodhound equipment. The Bloodhound has an integrated 4G and 5G modem. Currently, we carry AT&T and Verizon modem sets. One carrier may be better than the other in your final location. Please let tech support or the order desk know when ordering your Bloodhound what carrier you would prefer to use. This internal modem also has an integrated local Wi-Fi system. This will allow the operator to utilize the built-in Wi-Fi system to gain access to the internet. This internet connectivity allows for the logger to upload the daily report to the geologist, do daily emails, and conduct any business wirelessly. This eliminates the need to connect to the local Ethernet or Wi-Fi system supplied by the local rig. Many times the local rig will charge large fees to utilize the local Wi-Fi system. The Bloodhound helps eliminate these daily usage fees. The user can also connect to the Bloodhound through the wired Ethernet connection on the side for the same benefits. The amount of data that can be utilized by the logger on site can vary, but we recommend using less than 1 GB per month. Large video use over this data connection can cause data overruns and extra fees. The Bloodhound system has a Hobbs meter. This is simply an hour meter utilized for billing and service purposes. Every 4,000 hours, or 6 months, the Bloodhound needs to be returned to Eyeball Instruments for service, replacement of service items, firmware updates, checkout of sensors, and recalibration using NIST traceable calibration gases. At 3,500 hours of use, the Bloodhound will alarm the user that the 4,000-hour service time is becoming close, and that at the end of this job, the Bloodhound should be returned to Eyeball for service. The Bloodhound system is designed for high dust and dirt environments. The system keeps dust and dirt out of the case by utilizing a positive case pressure design. On the left-hand side of the case is a conical white dust filter. This filter must be in place the whole time the equipment is in operation. A fan will pull outside air through this filter and into the case. This positive internal pressure will keep dust and dirt from being drawn or leaked into the inside of the case. The exhaust of this positive pressure is found on the bottom of the case. Do not block this exhaust port on the bottom. Please place the Bloodhound on a hard surface like a table or countertop during use. This allows for proper airflow through the case and exhaust. Blocking this bottom exhaust may cause the Bloodhound to become hot inside, and an alarm will sound in that situation. On the underside of the lid of the Bloodhound, you'll find a black pouch. Within this pouch, you should find some placards showing the basic hookup of the Bloodhound system, a chromatograph verification sheet showing the last calibration of the chromatograph, and the manual for the Bloodhound 5 system. If you unzip the pouch, you will find a 120-volt power cord, 2 radio antennas, an Ethernet cord, and a female-to-female DB9 cord for a WITS serial interface. To identify the Bloodhound 5 series unit from the outside, the external serial number label will start with the number 5. This label will be yellow in color for an AT&T equipped unit and a white label for a Verizon equipped unit. Internally, when powered up and running, the internal LCD screen will also show the serial number starting with the number 5. Getting connected with the Bloodhound 5. The Bloodhound 5 has numerous gas and electrical connections on the left-hand side to interface with the outside world. The left-hand side of the case is where all the electrical, mechanical, and gaseous connections to the instrument are made. This is where you plug the incoming gas sample line. Next is the exhaust outlet. The inlet line is 1/4 inch ID in size, and the exhaust is 1/2 inch ID. This is on purpose to help alleviate connecting the inlet and exhaust on backwards. Because of possible ongoing long-term condensation, the exhaust line should always be in a downward run. This is to allow any condensation to run out of the exhaust tubing. If the exhaust tubing gets blocked or frozen over in winter, the Bloodhound will alarm for a blocked or occluded exhaust line. Never use a 1/4 inch ID exhaust line on the Bloodhound. Always use at least a 1/2 inch ID exhaust line, since any appreciable back pressure may cause readings to be less accurate or waver. This small 1/8 inch hose barb connector is the exhaust from the internal chromatograph system. The exhaust from this system is not harmful and is measured in microliters per minute. It is important that it is not blocked in any way, since back pressure on this connector will cause erroneous readings for the chromatograph system. There are still many loggers out there that are using a mechanical geolograph system. This connector is a spring-loaded connector for 2 wires that travel to the geolograph switch. Much like a spring-loaded speaker connector, just press down on the connector and insert the stripped wire to each connector. When the geolograph switch is tripped, the depth will be incremented by 1 foot. This round military-style connector is the RS422 serial connector for the Payson WITS system. Most of the PACE WITS systems have been converted over to the 9-pin WITS system, and over time these PACE system connectors will be phased out. Normally, this connector is connected to a thick, large cable that goes to the tool pusher shack or the company man shack or wherever the PACE computer is located for connection. Once connected, the Bloodhound should start reading WITS information immediately. More often, the company man or tool pusher will supply the logging trailer with a WITS computer. On the back of this WITS computer will be found a normal 9-pin male serial connection. The computer connection needs to be connected to this 9-pin male connection on the Bloodhound using a null modem cable found in the pouch of the Bloodhound instrument in order to receive on-site WITS information. Next down is a 9-pin female serial connector used for gas chart. This is not a WITS connector. To date, this connector is obsolete and is no longer used. It will accept and provide the same data as the USB-B connector, but in an older physical format. Right next to that connector is a USB-B connector. This is the main interface serial connection between the Bloodhound and the local computer. This is the same type of cable as a serial printer cable. In the pouch of the Bloodhound, you will find provided for you a USB-A to USB-B cable. This cable should be used to connect the Bloodhound instrument to the local computer running gas chart. This gas chart computer can be a laptop, a desktop, or other PC-based computer running any version of Windows, including Windows 11. If you do not have AC voltage available to run the Bloodhound can be powered by an external 12-volt DC source when connected to this red and black screw terminal connector. This connector can also be a 12-volt DC output to power the eyeball instrument's cavitator extractor or a separate 12-volt DC device. The current limit of this output is limited to 5 amps. Next is a 120-volt or 220-volt AC power input port. This is the same connector that is found on most modern desktop computers. By plugging AC power to this port, the Bloodhound will power up and start operating. To turn the Bloodhound off, disconnect the power cord from this connector and hit the upper left-hand red button on the face of the Bloodhound. It will then shut off. If there's a power disruption, an alarm will sound to notify you of a power disruption. The 4G or 5G cellular antenna is connected here at this port. This will allow the Bloodhound to connect to the cellular system for internet traffic. Make sure the antenna is outside and on a metal surface for best operation. The Bloodhound has a SON alert system on the side. This SON alert system will turn on when there's a problem that the Bloodhound needs an operator to attend to in short order. Reason for the alarm will appear on the LCD screen on the main faceplate. The 8-pin RJ45 connector is for Internet Ethernet connection. The Bloodhound can either supply an internet connection through this connection, or it can use an external internet connection to this RJ45 port. If register 55 is set to 0, then the Bloodhound is expecting for the user to connect an external Ethernet connection with DHCP active. This will allow the Bloodhound to use an external internet source to connect to the internet through your supplied connection. If register 55 is set to 1, then the internal 4G or 5G modem is active. With this modem active, the Bloodhound is using it for an internet connection, and this Ethernet port will supply an internet connection to you. Do not have register 55 set to 1 or modem active and connect a live Ethernet connection to the Ethernet port. This will allow the local LAN to utilize the Bloodhound internet connection to everyone connected. More on registers and what register settings are later in this video. The Bloodhound communicates to multiple items simultaneously. When the Bloodhound is powered up and operating, it is first communicating to a local laptop or PC through the USB-A to USB-B cable. This computer or laptop will be running the gas chart software that allows a local operator to monitor, operate, and control the Bloodhound gas detector. The Bloodhound will also be connected to a local WITS source which will supply WITS information to the Bloodhound. This WITS information will be coming through the 9-pin female-to-female WITS cable. The Bloodhound will share this WITS information with gas chart and the eyeball server system if the Bloodhound is connected to the internet. The Bloodhound can also be connected to the internet through either the 3G or 4G modem or a local Ethernet connection that supplies a connection to the internet. The PC or laptop can piggyback on this internet connection and also connect to the internet using the same path as the Bloodhound. The reason the Bloodhound should be connected to the internet is threefold. First, eyeball technical support can monitor, repair, change, assist, or adjust your Bloodhound device remotely, which will aid and support your efforts on site. Second, the Bloodhound and gas chart will communicate to the eyeball instrument's server system where your data is stored 1 packet at a time every 6 seconds. This data can later be retrieved as a backup or customers can monitor progress. Third, if your organization is using multiple Bloodhound systems, your local manager can remotely monitor all Bloodhounds, including yours, at the same time for progress, support, and troubleshooting. The benefits of connecting the Bloodhound to the internet is the Bloodhound server system. The Bloodhound server system allows users, customers, managers, or geologists to connect remotely to your work and the operation of the Bloodhound system. eyeballremote.com allows for a user to choose a serial number, then enter a username and password to gain real-time access to the current information and data on the Bloodhound device in operation. eyeballmultiview.com allows for a user or manager to monitor multiple Bloodhound devices at once for an overview of multiple devices. Through eyeballremote.com, technical support is also able to assist users on a real-time basis. Lastly is a standalone software program that allows yourself, your manager, or other authorized user the ability to assist in troubleshooting and assisting in problem-solving remotely using the Real-Time Data Viewer program. The Real-Time Data Viewer and gas chart programs can be found at eyeballinst.com or eyeballinst.com. eyeballremote.com can be utilized by iPads, iPhones, or any other tablet or smartphone device to help utilize the Bloodhound services remotely. The Bloodhound gas detector device is operated, adjusted, and set utilizing the console switches and one knob. A study of the LCD screen will allow the user to monitor in real time the date, time, and temperature of the Bloodhound device found on the top row of information. The second row of information shows the job number, serial number, and external version of firmware that the instrument is running on. It is always important to start a new job number at the start of a new well. Next, you have the hole depth in large double-sized letters, followed by the minutes per foot rate of penetration. Below that is the feet per hour in penetration. Just below that is the gas units. Gas units is a measure of combustible gases in air where 0 is no combustible gas and 10,000 is 100% combustible gas. To the right of the gas units, the user will find amps, which is the amount of amps being drawn from the DC port on the left-hand side. Below amps is the chromatograph pressure. If this falls low, the instrument will alarm. General numbers are around 1,000 millimeters of mercury. Lastly, in the middle is the sample line vacuum and sample line liters per hour, which is the flow rate of the sample gas being drawn into the Bloodhound instrument. Generally, the operator would want to keep the millimeters of mercury for the sample line below 100. The right-hand side, below the external version of firmware, are hydrogen sulfide in parts per million, oxygen percent, carbon dioxide percent, and received strength indicator in percent. When you receive the Bloodhound, the hydrogen sulfide sensor is deactivated and would need a register setting to activate it. These items help the user understand the current real-time operation of the instrument and to assist in troubleshooting any ongoing operational problems. The lower right of the LCD is a rotating display of information. This information will include not only the received strength indicator, but also the status of the WITS connection, the Hobbs use timer, the chromatograph countdown timer, the status of the internal storage of data, external data storage condition, whether or not the modem is currently connected, and what state it is in. If your Bloodhound is in the main log mode, it will also be displayed in this corner. Lastly, the local Internet Protocol or IP address will be displayed here as well. This is the internet address that the Bloodhound is currently using for its connection. First, any red key will return you from a submenu to the main display previously discussed. The upper left red Start-Stop button will shut down the Bloodhound if the power cord is disconnected. You may have to hold the key down for a few seconds if the Bloodhound is internally busy on a different process. The next one is the high vacuum indicator. If there is a high vacuum found on the sample line, somewhere above 180 millimeters of mercury, this indicator will glow red and an alarm will sound. On the lower left is the red sample system fault indicator. This will illuminate if there is a fault with the sample system, such as with a solenoid, pump, or pressure sensor. Multiple faults may cause this indicator to illuminate. An alarm will sound if this indicator is lit. If the chromatograph pressure starts to drop, the pressure fault red light will illuminate. For now, the checklist button serves no purpose. To access the function menu, hit the up and down arrow keys at the same time. When this is performed, a new menu will appear on the LCD screen, allowing the user to access more setup functions for the Bloodhound operations. These additional functions include setting the job number, setting the current depth, changing register control values, as well as many other functions not covered in this video. The mute green key will mute the audio alarm of the Bloodhound when pressed. If pressed a second time in short order, the mute will be cancelled. If pressed again, the mute will become active again. This mute key is also the enter key. If a function is selected or changed, this mute enter key needs to be pressed to enter the new value or function. The upper USB-A socket is for a USB flash drive. This flash drive socket should be populated from the factory with the USB flash drive. This is the backup storage of data as the Bloodhound is operating. This drive also holds copies of all the programs you would need on site to operate the Bloodhound, such as gas chart. The lower USB-A socket, if supplied, is inoperable and should not be used. Additional functions and setup of the Bloodhound can be found and set up using the knob to the left of the control panel. If the user rotates this knob, the LCD will show a new set of functions that the user can select. Clicking the knob one detent at a time will bring up a different function per detent. To select a function to adjust, just rotate the knob to select the desired function, then hit the mute enter key. These functions include gas units zeroing, calibration items, zero items, span adjustment items, and numerous others. This allows the user to adjust and calibrate the Bloodhound using NIST gases when needed. By hitting the up and down arrow keys on the control panel, the setup menu will appear. As an example of how to use the setup menu, let's go over how to set the drill depth on the Bloodhound. First, hit the up and down arrow keys. The current depth is 150 feet. Let's change the depth to 100 feet. Hit the down arrow key until the item depth counter is shown. Hit the mute enter key to select the function to change the depth. Once the drill depth is shown, hit or hold the up or down arrow key to change the current depth of 150 to the new depth of 100. Then hit the mute enter key once again to set the new depth into memory. The infrared detection system, or IR for short, utilizes infrared light to detect hydrocarbons coming in from the sample lines. This is not a hot wire style of detection device. Because the Bloodhound system uses IR to detect hydrocarbons, there is no actual combustion of the hydrocarbon elements and is known as a non-destructive detection method. This method is more inherently and intrinsically safe. Also, because of the IR system, no damage can possibly occur if too much hydrocarbon gas enters the test chamber. In older style pilaster or hot wire systems, if more than 5% of hydrocarbon gas enter the test chamber, damage would always occur, and sometimes the outright failure of the instrument is the result. This cannot happen with the Bloodhound IR system of detection. The IR system is also very responsive to the hydrocarbon gases. This is due to the ability of hydrocarbon gases to absorb infrared light. As more hydrocarbon gas enters the test chamber, more infrared light is absorbed. A sensor that detects infrared light will detect this loss of infrared light and create an output relative to the amount of infrared light absorbed by the hydrocarbons. Here we can see a partially disassembled detector block within the Bloodhound system. As air flows through the red detector block, the sensors do not have any infrared absorbed since there is no hydrocarbon gas present. As a hydrocarbon gas is introduced, the IR sensor will have some of the infrared light absorbed. This allows for the sensor to create a defection and an output relative to the amount of hydrocarbon gas being introduced into the detection block. Since the output of the gas block is digital in nature, the Bloodhound has the ability to adjust that output into two different scales, a standard scale and an enhanced scale. The definition of a gas unit. A gas unit is a scaled measurement of a mixed amount of hydrocarbon-based gas in air. One gas unit is 1/100th of 1%. As an example, 100% of methane in air would read 10,000 gas units. As another example, 10% of methane in air would read 1,000 gas units. The gas chart software is a real-time interactive software utilized to interface to the Bloodhound instrument. As shown, there are 2 charts on this page after running the program. This program will also generate the files needed to populate your log or log report through exporting industry standard LAS files either automatically or on demand. Third-party logging programs such as WellSite software can be configured to automatically import the LAS files that the Bloodhound generates on a periodic basis. Gas chart can be utilized both directly connected to the Bloodhound through the USB-A to USB-B cable, as well as remotely through the internet. When gas chart software is communicating to the Bloodhound, it will automatically calculate the gas unit's lag for you as well, since the Bloodhound gas detector does not have the ability to calculate lag automatically without gas chart operating and communicating to the Bloodhound. Since gas chart interfaces with the Bloodhound device, it can also monitor the operation, status, as well as communications to and from the rig while in operation. When starting up gas chart, the screen will be split into 2 areas. The left side is for rate of penetration in black and lagged gas units in red. The right-hand side is real-time charting of the selected charting items. Date and time will be displayed on the right-hand side of the data collected. The top will show what items are currently being displayed. The last database used will be loaded upon loading of gas chart. However, upon a first startup of the program, a demonstration database will be loaded. Right-clicking anywhere inside the program window will bring up the gas chart control box. This control box will allow the user to further select all control options going forward. Zooming in and zooming out controls will allow the user to see more or less data on the screen. The large triangle up and triangle down will allow the user to move up and down in time to view earlier or later parts of the chart. If you hold down the control key, then clicking and holding on the screen and pulling the mouse up and down, the user will be able to quickly move up and down the chart data. On the far left, there is a stack of depth numbers. This represents the start and end of the database in drill depth. Clicking on one of these will quickly move you to that part of the database based on drill depth. Clicking at the top of this stack will take you to the beginning of the database. Clicking at the bottom will take you closer to the current time. On the gas chart control box, there is a button for real-time data. Clicking on this button will bring up the real-time data for the Bloodhound. This data is directly coming from the Bloodhound device. The larger items include the current gas units, drill depth, and rate of penetration, and followed by the calculated lag depth. Currently, in this demonstration, the large yellow box shows that the drill is off bottom. When the drill is on bottom, the yellow will turn back to black. As the program goes forward and captures more real-time data instead of demonstration data, the calculated lag will become more accurate. Toward the middle of the real-time box are the C values: methane, ethane, propane, butanes, and pentanes. In this example, only methane is coming out of the chromatograph. In the middle are the vital statistics of the operating Bloodhound device. To begin with, the 3 most important items of note are the sample line vacuum, sample flow rate, and sample motor percentage. The sample motor percentage will increase or decrease to allow the sample flow rate to regulate and maintain 60 liters per minute. If the sample line vacuum is too high, such as over 180 millimeters of mercury, then the Bloodhound will alarm with a sample line blocked alarm. Monitoring these 3 variables from the Bloodhound will help the user check for sample lines that are becoming clogged or filled with condensation. The rest of the center real-time values have to do with internal operations of the Bloodhound device and is not covered in this video, but many of them should be mostly apparent to the operator. When talking to technical support, they may ask you to look at these values with them. On the right-hand side of the real-time box is the live WITS information coming in from the rig. Some of the most common WITS channels are 108, which is bit depth, and 110, which is hole depth. These numbers will be reflected on the right-hand side of the box as well. Normally, channel 123 will be present, which is the pump stroke per minute. In order for gas chart to correctly calculate lag depth, at least 1 channel of pump strokes per minute will need to be coming over WITS. In addition to these channels that are used by the Bloodhound system, there are usually many more WITS channels displayed while the rig operation is ongoing. Some other channels a logger may use from this list are the gamma values. Most of these values are not within the scope of this video. Ways to select real-time data. When the user double-clicks on the data chart, a flashing line will appear and will be attached to the end of the cursor. This is the selection line. This selection line will have a small green box that will notate the amount of time the user is selecting. By double-clicking again, the user will have selected an amount of time to manipulate or explore, and a secondary selection box will appear. Within this box is the ability to select a number of items. In this example, we are going to select View Chromatograph. Upon selecting the View Chromatograph button, a new window will appear, which is the chromatograph output window. This window will show data relating to a single chromatogram output. Currently, the gain is too high and the peaks are outside of the window. As an example, to reduce the visual gain of the chromatogram waveform output, a slider is provided on the right-hand side. This slider will adjust for the user the size of the displayed chromatogram. The user is also able to move the whole chromatogram up and down by clicking and holding on the chromatogram and dragging the cursor up and down. Numerous items are shown in this window that are directly related to the chromatograph output. Each chromatogram has a unique chromatogram injection ID. This may become important when talking to technical support over the phone. The user is able to select previous and subsequent chromatograms by selecting the Next and Previous buttons found at the top of the chromatograph window. Other points of information include the percentages of gases detected through the chromatograph, the rate of penetration, the amount of time for each injection, the time between each peak detected, as well as other detected gases at the time of the injection of sample gas into the chromatograph. If you are connected locally or connected via two-way communications, the user will be able to set timing peaks. As an example, if the user would like to correct for the peak timing of C1 or methane, then just press Set C1 Peak and a vertical line will appear. Just set the line on top of the C1 peak and click. This will automatically set the timing for the C1 peak into the computer. All successive peak timings will be based on that new setting. Right-clicking on the main screen brings back up the gas chart control box. If the gas chart program is connected to the Bloodhound, then a green Connected button will show how the gas chart is connected as well as a percentage connected. Currently, this shows TCP and 100%. This box also shows in green that the WITS interface is connected and that currently there is about 56 strokes per minute on the rig pumps that will allow for the calculation of lag times. These buttons allow the user to turn these items on and off in case you are using a geolograph or other logging method other than WITS. Opening this window, the user can set up the gas chart program and operations. Auto, ROP, and lag. This is a rather simplified lag engine. The user can generate lag timing by time over depth, or if you have WITS connectivity through pump strokes. This is selected by the radio buttons on the bottom right. So if you utilize time over depth, then the program is going to use the minutes of lag per 100 foot. The blue highlighted items are controlled by WITS data. If you select Generate Lag using pump strokes, then Gas Chart will use the strokes per 100 foot box. Currently, there's only one zone to select from. Other items in this control section will not be covered in this video. Generation of LAS and XLS files. This function is one of the more important parts of the program. This section allows the user to generate the needed files to import into your choice of logging programs, such as WellSite or MainLog. For most customers, leaving the LAS file generation format to 1.1 works best. LAS files are text files that allow for the transfer of data from Gas Chart to your logging program of choice. Gas Chart can generate the LAS file either manually or on a timed schedule. Also, most customers prefer and need to have the depth count to be lagged, so it should be selected as well. The upper half of this window allows for the user to select how the LAS and XLS files are to be generated, including an additional last 48 hours file and adding headers to the file. The XLS files are generally used for advanced data collection and automatic generation for third-party data collection programs not associated with Gas Chart. Most customers use the LAS formation of files. Automatic LAS file generation is performed by selecting a value other than 0 for the number of minutes between each file generation, as well as a subdirectory to place it in. The units of measure for C values can be selected for the LAS files. They're usually in parts per million, but can also be in gas units, a percentage of gas units, or a percentage of total sample gas. When selecting this unit of measure, it will not impact the total gas units. If you need to reduce or increase the amount of units of measure, it has that ability too through the C value gain setting. You can also choose between having the rate of penetration in either feet per hour or minutes per foot. The output LAS file is normally delineated by tabs. However, the user can choose between tabs, comma, space, or a special character depending on your needs. GasChart has the ability to generate a LAS file between specific depths if needed by your application. By unchecking this box, GasChart will utilize a preset minimum and maximum value. Be careful to not leave this box unchecked if you need an LAS file with the full database generated. Changes in charting. GasChart has the ability to allow the user to select what is viewable at any given moment. On the left side of this tab are the chart items. General chartable items include gas units, the C values, the raw chromatograph output, oxygen, carbon dioxide, hydrogen sulfide, peak tags for the gas units, an edited geolograph where the user has made changes to it, the raw chromatograph, an orange-colored off-bottom notation, as well as a blue pumps on and off indicator showing when the pumps are active and inactive. The most used items are the gas units, oxygen, C values, edited geolograph, off-bottom, and pumps on and off. After changing the selection boxes, the chart will regenerate in a minute or two and show the new traces and lines on the main screen. However, you can also choose to hit Redraw Chart or Reset View to generate a new chart instantly. The Chart Diagnostics Items column allows for the user to help troubleshoot the Bloodhound during operation. Sample line vacuum and flow will show trends of flow and vacuum, and if there are any problems with the sample line plugging up or gathering condensation. Exhaust pressure would show a trend in a freezing exhaust line. Case temperature, HRM temperature, and chromatograph temperature allow you to view trends in temperature over time. Chromatograph pressure will allow the viewing of any trend changes on the chromatograph pressure. The most used items in this section would be sample line vacuum pressure and case temperature. The oil indicator allows the user to choose a theoretical formula to help calculate the values and percentages of an oil indicator. The actual formula utilized to calculate the output is shown in blue right next to the radio button selection. These methods help some customers determine the chances of oil versus gas extractions. To chart some specific WITS items, GasChart has the ability to generate charts for total strokes per minute, total strokes, inclination, azimuth, and gamma. On the bottom left, the user can make adjustments and add charting modifiers. If the user wants to have as a function more gain in C1, then the C1 gain can be increased above 1, or if the user wants to decrease the value, make it a fraction below 1. Also, the user can select to show or not show a C value, or even change the color by clicking on the C value color to change. Some chartable items are automatically scaled, some are not. In this section, a few items are manually scaled. These include a gas unit scale, WITS display scale, oil indicator scale, a rate of penetration scale, and a gamma lag scale. After changes, the user can hit the Redraw Chart button and view the newly generated chart with the new options added. The Bloodhound tab. The Bloodhound tab allows the user to communicate to the Bloodhound device or set GasChart up to connect to the Bloodhound device. The Bloodhound settings box allows for the user to set individual values for individual functions or directly send a command to the Bloodhound device. More importantly is the ability to set GasChart up to connect to the Bloodhound device. GasChart can connect to the Bloodhound device through either the USB cable connection or through an Ethernet connection. This Ethernet connection can also allow GasChart to connect to the Bloodhound over the local Ethernet or through the internet. By selecting either the Use Serial/USB connection or Use Ethernet radio button, the user first selects the cable that is going to be used to communicate to the Bloodhound. Next, the user selects the serial number of the Bloodhound if the user is going to connect to the Bloodhound over the internet. If the user is going to connect to the Bloodhound locally through an Ethernet cable, then the bottom right-hand box needs to contain the local IP address. This IP address will be momentarily displayed on the lower right-hand side of the LCD screen. This number will look something like 192.168.10.100:22. This number needs to be entered in this address box for gas chart to connect locally to the Bloodhound through the Ethernet cable. On the gas chart control box, there's a bank of buttons called the Chart Data section. This section contains buttons that have to do with file generation and database manipulation. When the user wants to manually generate an LAS file, the first button on the top is hit. When it is hit, an LAS file will be generated and placed at the file's previously aforementioned location. Generally, this will be under the Program Files/eyeball/dbq subfolder. The Export DB to IBD text file button allows the user to generate an easily viewable and usable text file. This text file can be used for other programs or for data analyzation by other systems. This generated text file will contain all the data that the database holds, and it will be comma delineated to allow for direct import into Microsoft products such as Excel. Importing an IBD text file into the database is just as easy by selecting the Import IBD or Text File button. When selecting this button, a file selection window will pop up and the user will be able to select a file location and name. After doing so, gas chart will import the IBD text file. This may take a few minutes as the file is imported, sorted, and stored into the current database. After gas chart starts up, the last database that was being used is loaded into memory for use. If the user wishes to open up another database that is already on the hard drive, then the Open Database button should be hit. When selecting this button, the current database is closed and then a file selection window will pop up and the user will be able to select a file location and name. After doing so, gas chart will import the selected database file. This may take a few minutes as the file is imported, sorted, and stored into the current database. Sometimes the user wants to save the current database as a separate file or file name. By selecting the Save Database button, a file selection window will pop up and the user will be able to select a new file location and new name to save the current database as. After doing so, gas chart will save the current database under the new location and name. However, the current database is not changed and is still being used. If directed by the gas chart program or if directed by technical support, the Compact Repair Database button should be hit. While the user can hit this button at any time without problem, this button is utilized in case the database has been corrupted by a power fault, sudden shutdowns, or other erroneous condition that has caused the current database to become corrupted in some manner. If you experience a database error and after hitting the Compact Repair Database button the problem persists, please call technical support at 405-570-4449. Below these buttons, the user will find the Notes text box. This box is utilized by gas chart to give messages to the user. Some messages are errors that can be helpful to collect problems, and some may be more cryptic to help technical support. If for some reason you see an error continuously appear in this text box, please contact technical support at 405-570-4449. The Eyeball Instruments Real-Time Data Viewer is a standalone program that allows the user to monitor the real-time data generated and transmitted from the Bloodhound device. This includes a remote quick view of the Bloodhound status. It is ideal for operational centers to monitor multiple units at the same time. It allows for easy access to remote control diagnostics as well as remote control of the Bloodhound device itself. The Real-Time Data Viewer shows all the same real-time items that the user could see in gas chart. By hitting the More Data button at the top, the window is expanded to show a black and yellow raw data window. When the user enters an active Bloodhound number in the upper left-hand side and hits the Connect button, raw real-time data will be displayed in the program. This includes the gas units, hole depth, rate of penetration, and lag depth. Operational parameters include carbon dioxide, oxygen, sample vacuum, motor percent, C values, and on the right-hand side, any WITS values currently coming into the Bloodhound device. If the user has a correct username and password, then a two-way communications path can be linked. If so, this allows the user to have remote console command of the Bloodhound device. With two-way communications, the user can perform line commands to the Bloodhound for service, adjustments, or maintenance from a remote location. Lastly, the user can run multiple instances of Real-Time Data Viewer to monitor multiple Bloodhounds at the same time. Eyeballinst.com or IBALLINST.com is the main website for Eyeball Instruments. Here the user can find general information about the company, products, or contact information. Furthermore, all documentation can be easily downloaded. In the download section, the user can download any of the programs needed to operate the Bloodhound system. First are the drivers to allow for the connection between a Windows-based computer and the Bloodhound system, and then the gas chart program. The drivers are compatible for all versions of Windows that you may have and are digitally signed for code protection. Gas chart is shown below and is also digitally signed for code protection. All manuals are available for the user to download as well. Finally, the user can also find tools such as a witch simulator, in case the user would like to test the witch system out before actually hooking up to the well site witch system, or if the user would like to test with the Bloodhound system in the shop before deploying out into the field. The real-time data viewer is also available for download. These documents and files can also be found on the USB thumb drive found on the faceplate of the Bloodhound device as well. Eyeball Remote, or IBALLREMOTE.com, is the website used by customers to access and monitor active Bloodhound devices. Every Bloodhound device has the ability to be monitored remotely if the user desires. If the user does not require, need, or want this service, then all the user has to do is not connect the Bloodhound to the internet. When visiting the Eyeball Remote site, the user is presented with a request for a serial number of the Bloodhound to remotely monitor. After entering a 4-digit serial number of the Bloodhound, a new screen is shown showing a required username and password for the Bloodhound in question. This password for the requested serial number needs to have been set up by the supervisor of the Bloodhound or by Eyeball Instruments technical support staff. Once a correct username and password has been entered, the user is presented with the main screen. This screen shows the real-time data of the serial numbered Bloodhound. This information is the same information as found within the real-time data viewer as previously discussed. Above the real-time data viewer is an area that the user can utilize to personally brand the website to show their personal or business logo. Further, the user can add notes to other users of the site. The website also has the ability to automatically generate LAS and XLS files for the user in real time. Administrator-level users can actually create and generate the actual database file for the user to download and install into a local copy of Gas Chart if needed. Also showing for the user is the actual charting information for the operational Bloodhound system. The user can go into the charting options and select numerous items to change. This includes many items also found in the previous description of Gas Chart. The user can adjust scales, colors, and a new feature is the ability to fill in missing data. Occasionally, the server system will drop some packets. If requested, the server system can insert this missing data for the user. Other items that the user can change are the scales for different charting items. This includes not only the gas unit scale, but also rate of penetration, the maximum number of chart pages to generate on the main page, gamma scale, and how often the chart will be regenerated and refreshed. After any changes are made, the user must select Save Changes button on the top or bottom of this page in order for the changes to take effect. Once the Save Changes button is hit, it may take a minute to regenerate the main charting page. The Automated Alert section allows the user to set general and common alerts for the Bloodhound system. The Automated Alert section requires an email or smartphone number in order for the server system to send the user or users an alert. If you are an administrator, you are also able to get into the Edit Passwords section. This will allow the user to set up passwords for other administrators, users, managers, or just a viewer level of access. When the user is granted administrator level for the first time, the technical support staff will have already cleared out any previous data and reset the server interface to the basic level that is ready for the user's input and edits. Eyeball Multiview is a website that allows a manager or company owner to monitor multiple Bloodhounds at the same time easily through one web interface. When first visiting the Eyeball Multiview website, the user will be presented with an Add New Bloodhound Units opening screen. This is the website asking for Bloodhound serial numbers to monitor. By selecting the Unit ID entry and an optional lease name and lease notes, the user will enter a Bloodhound to be monitored. By doing so, the user is creating a list. The list can be viewed at the bottom of the Setup web page. Entering a second serial number and optional notes will add a second serial number to the same list below. As a third example, adding a third serial number and optional lease name will also add this serial number to the list below. The user can maintain this list by selecting and deleting items that the user no longer wants to monitor. After the list of Bloodhounds is complete, just hit the Return to Multiview button to return to the main screen. When returning to the main multiview screen, the user will be presented with the list of Bloodhounds previously entered in sequential order. Items that are readily viewable on the main screen are status, uptime, lease, gas units, Hobbs timer, and hole depth. By hovering over the Bloodhound unit number, a real-time screen will pop up, giving even more data that is available to the user in order for the user to more closely monitor real-time data coming from the Bloodhound instrument. By clicking on the Bloodhound serial number, the user will be taken to a new tab which will ask for a username and password for that particular serial number. When entered, the user is taken to the online charting of the Bloodhound in question from Eyeball Remote. eyeballhelp.com IBALLHELP.com. Powered by Google Search and other search technology, eyeballhelp.com is a Bloodhound bootcamp website for new employees or users of the Bloodhound system. There, the user can find much needed information and resources needed to utilize the Bloodhound system in a concise, easy to read and reach manner. The Bloodhound bootcamp is broken into 3 steps for the user. First step is to become familiar with the Bloodhound system. The second step is to download and load the software to the local computer using the Bloodhound system. The third step is to ask questions that may already be answered with questions found in the knowledge base. Finally, never hesitate to call 405-570-4449 at any time, 24 hours per day, for customer and technical assistance on any Bloodhound or Eyeball Instruments related item. Thank you.